A simple ASP.NET Web API could look like this. It starts with an endpoint definition, then the request parameters are passed, and the business logic is called. Once the business logic is completed, the response is passed to the framework, which converts it into JSON and sends it to the UI framework like Angular, React, or Vue.js. But as simple as this implementation seems to be, it will get you into severe trouble as the project grows. And here's why. It might not be obvious, as the transfer of the response object to the UI magically happens by the framework, but such a controller implementation exposes the application logic and maybe even the domain model APIs to the UI, which means the structure of these objects, the property names, and the relationships are known to the UI. Such an implementation effectively couples the UI to the design of the application logic and the domain model, and vice versa. As a consequence, any refactoring of the business logic or the domain model may have an impact on the UI, means you have to find and adapt all the relevant places in the UI, which will become a severe pain easily as your project grows. For the purpose of this tutorial, I kept the domain model intentionally simple, but imagine a more realistic one with a multiple of objects. For example, we could have different work item types like improvements, work packages and user stories, and various value objects like area paths, iteration paths, and different work item states. In such a scenario, the problem of the pragmatic controller implementation becomes obvious. To avoid a disaster, we need an anti-corruption layer. For that, we introduce a ViewModel which defines an explicit contract to the UI. This contract would be optimized to be most convenient for the UI, to minimize the code needed to read and interpret the backend response. Such a design enables refactorings of the application logic and the domain model without directly impacting the UI. Of course, changes of the ViewModel would still break the UI, but such a change is a much more explicit decision, as the only purpose of the ViewModel is to serve as an API to the UI. In order to bring the ViewModel to life, we need some conversion logic in the controller. This code not only converts the structure of the application and domain model objects to the simplified structure of the ViewModel, but also converts specific data types used in the domain model to simple strings wherever possible. A similar approach of providing a dedicated contract object for the UI we would also introduce in cases where the backend receives data structures from the UI. The introduction of these request objects completes the anti-corruption layer for inputs sent to the backend and outputs returned by the backend. Which finally brings us to this control flow diagram described by Uncle Bob in his clean architecture. It clearly visualizes how the request object and the ViewModel serve as an anti-corruption layer between the application logic and the UI, and how the controller-presenter pair act as an adapter between both worlds. If we take a second look at the controller, we can clearly identify multiple responsibilities. The definition of the endpoint API, the parsing of the input data, the dispatching of the request to the application logic, the conversion of the application logic response to the ViewModel, and the conversion of the ViewModel to JSON, which is mostly done by the base class, so the ASP.NET Core framework. If we compare this controller implementation and its responsibilities with the diagram, we can identify the controller part which converts the request object, the team name and the iteration, to the request model, the backlog request model, by parsing and validating the input data. How much validation should we do in a controller? Well, ideally, it should be limited to validating data types, like checking whether a string is a valid number or a valid date. The validation of the business rules should be done by the application logic and the domain model. Furthermore, we can identify the presenter part, which creates the ViewModel by converting the data structures and data types of the application logic and the domain model into a format which is most convenient for the UI. This reduces the complexity of the UI and so reduces its testing efforts. And what about the ports? A port basically is an interface defined in the application layer which defines the contract between the controller-presenter pair and the application logic. Do we need an input port interface? Well, if you want to hide the concrete implementation of the application logic to the controller, then such an interface would be needed. In most of my projects, I do not use such interfaces. And do we need an output port interface? As ASP.NET demands a return value from the controller, it is most convenient to deal with the return value from the application logic directly, so an output port interface is mostly not needed. And there's one more key observation from this diagram. The controller-presenter pair is clearly located in the interface adapters layer, which means all this code should not be in the ASP.NET Controller class directly, because the ASP.NET Controller class, due to its dependency to the ASP.NET framework, would either have to be in the frameworks layer, or if we would put this class into the interface adapters layer, it would violate the dependency rule. Don't marry the framework if you don't have to. And in this case, I really don't see any need. But why is this important? Reason number one, future changes. If you couple your implementation to the framework, it is more difficult to replace the framework in future. Right now, the actual controller presenter code is independent from the framework, and it would be pretty easy to factor it out into a separate framework-independent class. But as to my experience, if APIs are accessible, over time those APIs will be used, and finally the code is fully wired with the framework. For example, framework-specific input validation attributes are used, or certain utilities are used, for example, to encode some URL. Now you might think that this could be easily fixed once necessary, but consider that successful projects live longer than expected and grow faster than expected. Imagine the project would have 100 controllers managed by 10 different teams. Such a code change to decouple the code from the framework would still be doable, but the coordination of all those changes across different teams would certainly not be much fun. And if you now argue that the need to migrate to a different framework is unrealistic, then consider the historical development of ASP.NET. We have seen ASP.NET Web Forms, ASP.NET MVC, the classic version, we have seen ASP.NET Core, we have seen ASP.NET Web API and Web API 2, and nowadays we have ASP.NET Minimal API. So who knows what will come next? Reason number two for not marrying the framework: testing. Tests should not depend on implementation details like the concrete web framework. We might have dedicated tests for testing the web API itself, but the majority of the acceptance tests should not be impacted by changes of the infrastructure. We could now think of testing the application logic directly without the controller, which would solve the problem of being impacted by changes of the infrastructure. But this would mean that the business logic, its APIs, the design, and maybe even the domain entities become an API to the test. The consequences would be very similar to the ones regarding the UI. Any refactoring of the application logic has direct impact on the tests. From that perspective, we should treat the UI and the tests quite similar. We should have an anti-corruption layer in both cases. The anti-corruption layer between application logic and tests, Uncle Bob calls Test API. In order to create such an anti-corruption layer, we would have to define dedicated request and response objects to be used by our tests. But actually, we already have such objects for a similar purpose. The request objects and the ViewModel types we have created earlier. Furthermore, it might anyhow be a good idea to test the code parsing a request as well as the code creating a ViewModel. Reusing the same types in our tests would also help us to detect ViewModel changes, which would break the web UI later on. All these thoughts show clear benefits of basing our acceptance tests upon the controller-presenter pair, including request objects and the ViewModel types. But of course without the dependency to the infrastructure, the ASP.NET framework. By the way, this is exactly the approach suggested by Uncle Bob in his book on clean architecture. So our next step would be to extract the code from the ASP.NET controller class. A simple approach would be to move the complete code out of the ASP.NET Controller class into a separate class located in the interface adapters layer and to keep it strictly separated from any ASP.NET type. As your project grows, consider moving this controller adapter class into a separate assembly as suggested in this video. Invalid request data we could handle by simply throwing an exception. In the frameworks layer we would then use such an ASP.NET MVC filter to convert the exception into a corresponding HTTP return code. This setup would not only decouple our controller logic from the ASP.NET framework, but would also allow us to reuse the entire code in our test API, and so would enable us to test it implicitly with our acceptance tests. In the original ASP.NET controller class, not much code would be left. It would just import the adapter controller and forward the request. The remaining responsibility of the ASP.NET Controller class would be to design the web API itself and to convert the ViewModel into JSON. We could keep this implementation this way and manually maintain it additionally to the actual controller implementation, which would not be much effort as there is not really any code to maintain. If you use convention-based routing instead of attribute-based routing, then these classes would almost be useless and we could consider generating these classes. And how this could be achieved easily, I show you in the end of this video. Another approach to simplify the boilerplate code even further would be to use the ASP.NET Minimal API. As the API definition grows, it could be factored out into a dedicated file to maintain a better overview on the exposed web APIs. Let's have one more look at the control flow diagram from the clean architecture. In this picture, the controller and the presenter are visualized as separate classes. In our current design, the controller and the presenter code are in the same class. Should we change our design to align it with the one suggested by Uncle Bob? Of course, we could move the presenter code into a separate class, but actually, I don't see much value in it in the context of the ASP.NET framework. As the ASP.NET framework demands a return value from its controllers, we anyhow would have to call the presenter from the controller to convert the response of the application logic into the ViewModel. If you have an alternative design proposal which is closer to the one suggested by Uncle Bob, please let me know in the comments. And this is how I would recommend to design and implement controllers in the clean architecture. Usually I would argue that design decisions heavily depend on the concrete project, but as in this case the benefits of the clean solution clearly outbalance the costs, I recommend always use a dedicated ViewModel type and don't marry the framework. And if you now want to know how to generate these ASP.NET controller classes with just a few simple steps, then watch this video now.